imagine a perfect machine. A car built for kings, rock stars, and winners. In 1962, owning a Ferrari meant you had reached the top of the world. But for one man in Italy, this car became the greatest disappointment of his life. Ferruccio Lamborghini was a multimillionaire. He built a massive fortune after World War II by creating tractors from abandoned military hardware. He loved fast cars and bought several brand new Ferrari 250 GTs. There was just one catch. They constantly broke down. The clutches in these cars burned out so often that Ferruccio got tired of sending the cars back to the mechanics in Maranello. Being an experienced engineer himself, he decided to visit the factory and speak personally with the creator, the great Il Commendatore, Enzo Ferrari. Ferruccio offered Enzo an idea on how to improve the clutch assembly so it could handle the insane torque of the V12 engine. But Enzo Ferrari wasn't just an engineer. He was a dictator. He despised the clients who bought his road cars, considering them merely wallets to fund his true passion, the Formula One racing team. Enzo looked at Ferruccio and uttered a phrase that changed automotive history forever. "The car works perfectly. The problem is you. You may be able to drive a tractor, but you will never be able to handle a Ferrari." For anyone else, this would have been a humiliation. But Enzo Ferrari had no idea who he was dealing with. Ferruccio Lamborghini was born under the sign of Taurus. He was stubborn, ruthless in business, and a mechanical genius. He returned to his garage, dismantled the burnt clutch of his Ferrari, and made a shocking discovery, which we will show you a bit later. On that day, he swore not just to build a supercar. He swore to build the perfect machine that would make Enzo Ferrari regret his words. This is not just a story about speed. This is a story about physics, resentment, and the greatest Italian revenge. To understand how Lamborghini created the perfect supercar, you have to understand where he started. After World War II, Italy lay in ruins. The economy was destroyed, and farmers were in desperate need of machinery. Ferruccio saw this not as a tragedy, but as a gold mine. He began buying abandoned Allied military trucks for pennies and converting them into agricultural tractors. Gasoline was incredibly expensive at the time. And this is where Ferruccio's genius shone through. He installed a special vaporizer on his tractors that allowed the engine to start on expensive gasoline. And then, once the engine warmed up, switch over to cheap diesel fuel. It was simple, crude, and incredibly effective. Lamborghini tractors became a symbol of absolute reliability. But let's look at the physics. What makes a tractor engine different from a racing Ferrari engine? It all comes down to two concepts: horsepower and torque. Horsepower is how fast you hit the wall. Torque is how far you take the wall with you. Ferruccio's engines were built for phenomenal torque. They didn't rev to 8,000 RPM. They were heavy, slow, but possessed so much pulling power they could move a mountain. This approach made Lamborghini one of the wealthiest men in Italy. By the early 60s, he owned an entire empire. He bought the best cars in the world, Mercedes, Jaguars, Maseratis. But none of them were perfect. And then he bought a Ferrari. And it was exactly that tractor torque which Ferruccio understood better than anyone else in the world. That helped him uncover Enzo Ferrari's dirty secret. Ferruccio loved his brand new Ferrari 250 GT. The car was magnificent on the open road, its engine singing like an operatic tenor. But in city traffic, it was absolute hell. The car jerked, the gears crunched into place, and the cabin regularly smelled of burning. To understand the problem, let's look inside. How does a clutch work? The engine is constantly spinning, but the wheels are not. The clutch is the bridge between them. It's two discs pressed together with massive force. When you release the pedal, they lock, and friction transfers the engine's energy to the wheels. The problem with Ferrari was physics. The V12 produced colossal power, but the contact area of the discs was too small. Under the slightest load, the discs would slip, overheat, and simply turn to dust. After yet another breakdown, Lamborghini's patience snapped. He drove the Ferrari into his own tractor factory and ordered his engineers to dismantle the clutch assembly. When they pulled the part out into the light, Ferruccio saw something that sent him into a rage. The part bore the stamp, Borg and Beck. This wasn't some secret Ferrari development. It was a standard clutch that Ferruccio installed on his tractors. There was only one difference. Enzo Ferrari was selling this part for 10 times its actual cost, just for the brand. Ferruccio Lamborghini didn't just want to build a car. He wanted to build a temple of speed that would be visible from Enzo Ferrari's own windows. In late 1962, he purchased a massive plot of land in Sant'Agata Bolognese. It was a strategic move. Only 30 kilometers separated the two future arch-enemies. While competitors took years to build their workshops, Ferruccio acted with the fury of a tractor tycoon. In a record-breaking 8 months, a factory rose from an empty field that looked more like a space lab than a car repair shop. Huge windows, sterile cleanliness, and the latest equipment. He was building the stage for the greatest drama in Italian history. But walls don't make cars. People do. And here, fate dealt Enzo Ferrari a counter-strike. A revolt was brewing in Maranello. Enzo was a genius, but he was unbearable. His wife, Laura, constantly interfered with the engineer's work, leading to the Great Walkout of 1961. In a single day, Ferrari lost his best people, the ones who created his legend. Giotto Bizzarini, Carlo Chitti, and several other key figures found themselves on the street. To Enzo, they were traitors. To Ferruccio, they were a gift from heaven. He didn't just hire them, he gave them something they never had at Ferrari: total creative freedom and an unlimited budget. Lamborghini understood. To defeat a god, you must hire those who built his Olympus. Alongside the experienced Bizzarini stood young talents: Giampaolo Dallara, just 24 years old, and Paolo Stanzani. This was the Avengers team of the automotive world. They had no fear of tradition. Lamborghini set one rule: we don't build race cars, we build Gran Turismo, the perfect car for a gentleman. This was a psychological attack on Ferrari. Enzo believed that only racing made a car great. Lamborghini, however, argued that greatness is when a car works flawlessly at 200 kilometers per hour while you listen to music and enjoy the ride. The battle of two philosophies began. A battle that would forever divide the world into fans of the horse and fans of the bull. When Giotto Bizzarini began his work, Ferruccio Lamborghini offered him a deal that was impossible to refuse. Lamborghini promised to pay a massive bonus for every extra horsepower Giotto could squeeze out beyond Ferrari's figures. It wasn't just about money. It was about honor. Bizzarini wanted to prove that Enzo Ferrari had made the biggest mistake of his life by firing him. He decided to build a 3.5-liter V12 that would have the specs of a racing car, but could still cruise smoothly through the streets of Rome. Giotto poured all his resentment into the blueprints, creating a system with a dry sump and 4 overhead camshafts. It was the architecture of the future, decades ahead of its time. But why a V12? What is the magic in that number? The answer lies in the complex science of mass balancing. In any engine, pistons move up and down at incredible speeds, creating inertial forces that try to tear the motor apart from within. In V8 or V6 engines, these forces aren't fully balanced. They create vibrations you can feel in the steering wheel. But a V12 is geometric perfection. It is essentially 2 inline-6 engines working as one. When one piston moves up, another moves down at the exact same millisecond, perfectly canceling out the inertia. This is called primary and secondary balance. A V12 engine doesn't just work, it spins smoothly and silently, like a giant turbine. It was this silky power that Lamborghini wanted to pit against the nervous and vibrating cars of Ferrari. Power is breathing. As we already know, to get fire, you need oxygen. Enzo Ferrari often equipped his road cars with small carburetors to make them calmer and cheaper to maintain. Lamborghini considered this cowardice. He fitted his engine with 6 massive twin-choke Weber carburetors. Each cylinder received its own dedicated airflow. This allowed the engine to breathe at RPM levels that were unreachable for competitors. But there was a catch. Such a system required surgical precision. If one carburetor provided slightly more fuel mixture than another, the perfect V12 symphony turned into a cacophony. Lamborghini's mechanics spent hours listening to the intake sound through special tubes, tuning the engine by ear just as one would tune a Stradivarius violin. When the first 350 GT engine prototype was ready, it was placed on a test stand. When Bizzarini hit the throttle, the roar was so powerful that windows in nearby buildings began to rattle. The engine produced 360 horsepower. It was more than Ferruccio had expected, and far more than he had asked for. For a moment, Lamborghini was terrified. He realized he had created not just a car, but a wild beast. Now he faced a new, even more difficult challenge: how to harness this fury and transform it into the most beautiful car in the world. Ferruccio Lamborghini was adamant. His company would only build comfortable Gran Turismo cars with front-mounted engines, no racing. But his young engineers, Dallara, Stanzani, and test pilot Bob Wallace, were obsessed with motorsport. They understood that to truly destroy Ferrari, they needed a car that broke all the rules. So, they committed an act of treason. Secretly from their boss, working late nights after their regular shifts, the trio began designing a revolutionary chassis codenamed P400. They decided to do what Enzo Ferrari considered impossible for a road car. They shoved the giant V12 not under the hood, but right behind the driver's back. But why put the engine in the back? It's pure physics, known as the polar moment of inertia. Imagine a figure skater on ice. When their arms are outstretched, they spin slowly. But the moment they pull their arms into the center of their body, their spinning speed instantly multiplies. A car works exactly the same way. The engine is the heaviest part of the vehicle. If it hangs over the front wheels, the car struggles to dive into a corner. But if you place this massive weight dead in the center of the car, between the axles, it will change direction at the speed of thought. However, space was critically limited. The engineers had to mount the V12 transversely, sideways, merging the engine and gearbox into one incredibly complex block of metal. When Ferruccio Lamborghini finally saw the project, he didn't fire the engineers. He was a businessman and realized, this will draw attention. At the 1965 Turin Auto Show, Lamborghini exhibited just the bare chassis. No body, no doors, no windows. Just tubes, a steering wheel, seats, and a giant engine. What happened next is unprecedented in history. People walked up to the stand and wrote blank checks to buy the car, without even knowing what it would look like. The naked chassis radiated such engineering fury that the Ferraris at the show looked like outdated wagons. Now, Lamborghini just needed clothes for this monster. The bodywork was entrusted to a 27-year-old designer, Marcello Gandini. He penned the Lamborghini Miura, the car that became Patient Zero, the very first supercar in history. It was so incredibly beautiful that it made people stop dead in the streets. But when Bob Wallace took it out on the track, a lethal engineering flaw was revealed. Gandini was not an aerodynamicist. He had created a profile that perfectly mimicked an airplane wing. Physics is ruthless. When air travels faster over a curved surface than underneath it, it creates lift. At speeds over 240 kilometers per hour, the front end of the Miura literally tried to take flight. The steering went completely numb, and the fuel tank, located in the front, made the nose even lighter as it emptied. Driving this beauty at the limit was a genuine game of Russian roulette. The Miura's aerodynamic lift problem required a radical solution. And in 1971, Marcello Gandini revolutionized design by killing all curved lines. He penned the Lamborghini Countach, a car that looked like a spaceship that had crash-landed in the Italian countryside. The wedge shape wasn't chosen just for aesthetics. It literally sliced through the air, forcing the oncoming airflow to press down on the bodywork, pinning the car to the asphalt. The engineers had also learned their lesson. They abandoned the transverse engine layout. In the Countach, the giant V12 was rotated longitudinally, front to back, and the heavy gearbox was shoved right between the driver and the passenger. This provided perfect weight distribution, but it created a new, entirely unexpected problem. To ensure the car could handle the power of the new V12 without twisting in corners, engineers created an ultra-rigid tubular space frame. Because of this design, the car's door sills became incredibly wide and high. When the designer tried to attach standard, outward-opening doors, it turned out to be physically impossible to exit the car in a normal parking space. The doors were simply too long. There was only one way out: open them upwards. Thus, the famous scissor doors were born. What is considered today as the ultimate symbol of show-off and luxury was originally a harsh engineering necessity. Furthermore, because of the tiny rear window, reversing a Countach was virtually impossible. Drivers had to open the scissor door, sit on that massive sill, and reverse while looking backward entirely outside the vehicle. By the late 70s, the world had changed. The global oil crisis struck. Selling V12 supercars that guzzled fuel by the gallon became almost impossible. The company found itself on the brink of bankruptcy. And then, Lamborghini decided to remember how their founder started. By building heavy, brutal machinery. They aimed to secure a lucrative contract from the US military to build a new all-terrain vehicle. The project was named Cheetah. The idea was insane. They took a heavy Chrysler 5.8 engine and mounted it in the rear like a Porsche. It was a disaster. The heavy rear end destroyed the handling, and the military chose the Humvee project instead. But Lamborghini didn't give up. They took the concept of a brutal off-roader, completely re-engineered it, and created the LM002, a machine that earned the nickname the Rambo Lambo. The engineering of the LM002 was absolute madness. They took the V12 engine straight out of the Countach supercar and shoved it under the hood of a 3-ton square tank. The aerodynamics of a brick were paired with 450 horsepower. The fuel consumption was so monstrous that engineers had to install a 290-liter fuel tank. Standard tires simply exploded or bogged down in the sand under the sheer weight of this machine. So, Lamborghini turned to Pirelli, especially for the LM002, They developed the unique Scorpion tires with Kevlar reinforcement. They could be driven even when completely flat, run-flat technology, and their tread was designed to act like tractor scoops, displacing sand. The LM002 didn't save the company from crisis, but it became the favorite toy of Arab sheikhs and proved one main point: a bull knows no obstacles. By the late 1990s, Lamborghini resembled an aging rock star. The company had passed from hand to hand, from Swiss businessmen to the American Chrysler Corporation and Indonesian investors. The cars still looked insane, but the build quality was atrocious. The cabin smelled of gasoline, the air conditioning didn't work, and the electronics had a mind of their own. The bull was dying. And then Ferdinand Piëch stepped onto the stage, the powerful head of the Volkswagen Group and Audi. In 1998, the Germans bought Lamborghini. The automotive world held its breath in terror. Would the cold, pedantic Audi kill the wild Italian soul and force the bull to march in formation? But a miracle happened. The Germans didn't kill the monster. They built a perfect cage for it. The first joint creation was the Lamborghini Murcielago, Spanish for bat. German precision gifted the car with reliability. Panel gaps became perfect, and the engine started in any weather. But the engineering remained completely insane. To cool the massive 6.2-liter V12, engineers introduced active aerodynamics. At speeds over 130 kilometers per hour, or when the engine got too hot, giant air intakes would automatically deploy from the rear shoulders of the car, looking exactly like bat wings. The car literally transformed on the move, greedily swallowing cold air. However, Audi's main innovation was a survival system for the driver, sending 600 horsepower exclusively to the rear wheels, turned a Lamborghini into a suicide machine. Any mistake with the throttle in a corner led to an instant spin-out. Audi brought in all-wheel drive technology, viscous traction, VT. How does this magic work? Between the front and rear axles, they installed a cylinder filled with a special silicone fluid. Packs of metal discs rotate within this fluid. As long as you drive straight, everything is calm. The car is rear-wheel drive. But if the rear wheels start to slip, their discs spin faster than the front ones. From the immense friction, the silicone fluid inside heats up in fractions of a second and solidifies. It completely locks the discs together, instantly transferring life-saving power to the front wheels, pulling the car out of a deadly slide. It is a triumph of polymer physics that has saved thousands of lives of wealthy owners. How do you tell a Lamborghini from a Ferrari blindfolded? It is not a matter of taste. It is a matter of physics. And the first thing that hits your sensors is the acoustics. A Lamborghini's sound is a primal clap of thunder. Its V12 utilizes a geometrically perfect crankshaft, where every cylinder's ignition firing is perfectly balanced. The exhaust system is engineered not to muffle the sound, but to resonate it, like the body of a Stradivarius violin. The sound is deeper, pulsating, and raw. It's not singing. It's a roar that makes your very diaphragm vibrate. The second test is the test of form. If a Ferrari is water, a Lamborghini is ice. Their design language doesn't try to negotiate with the air. It's not the aerodynamics of smooth airflow. It's the aerodynamics of an impact. Lamborghini's geometry is built on aggressive planes, hexagons, and triangles borrowed from stealth fighter jets. These are chiseled, faceted forms, carved from carbon fiber. A Lamborghini doesn't glide through the air. It punches a hole in it with its wedge shape. Touch the body of a Lambo, and you feel the edge of a blade, ready to cut you. It is the aesthetics of dominance. The third and most physical test is character. How the car transfers its fury to the asphalt. In an era of smooth dual-clutch transmissions that shift gears in milliseconds without a single jolt, Lamborghini on its V12 flagships deliberately used a completely different mechanism, the ISR robotic single-clutch gearbox. This wasn't backwardness. It was an engineering choice. Full throttle gear shifts take only 50 milliseconds, but they are accompanied by a brutal mechanical shock. With every gear change, you are literally kicked in the back with a sledgehammer. The car lets you feel the pure, primal fury of mechanics. A Lambo doesn't want to be comfortable. It wants you to remember exactly who is in charge. And the fourth test is philosophy. If a Ferrari is a Stradivarius violin, an instrument requiring precision tuning and incredible skill from the driver, then a Lamborghini is an M16 assault rifle. Ferrari was created to win on racetracks. It is a refined racing tool. Lamborghini was created to prove one man's right to exist. It is about ostentation, brutality, and absolute firepower. A bull knows no obstacles. By the early 2000s, the horsepower war had reached a dead end. Engines were getting bigger, which meant they were getting heavier. In physics, there is the inexorable law of Newton. Acceleration equals force divided by mass. A equals F over m. You can increase power indefinitely, but if the car weighs like a tank, it will never be fast in the corners. Traditional carbon fiber was light, but its production required manual labor. Weaving the threads and baking them took days. It wasn't suitable for mass production, so Lamborghini joined forces with aerospace giant Boeing and the University of Washington. They created a secret laboratory, ACSL, to revolutionize materials science and find the philosopher's stone of automotive engineering. And they created forged composite. The physics of this material are completely different. Instead of weaving long threads, engineers took chopped carbon fibers, mixed them with resin, and squeezed them under a monstrous pressure of 100 atmospheres. A part was baked not in days, but in 3 minutes. The texture wasn't a neat checkerboard. It looked like brutal black marble. The ultimate manifesto of this technology was the sexto elemento concept, sixth element, carbon on the periodic table. The car was made almost entirely of forged composite and weighed only 999 kilograms. With a V10 engine, it accelerated to 100 kilometers per hour in an unbelievable 2.5 seconds. Lamborghini proved, to defeat gravity, you don't necessarily need to build more muscle. You just need to shed the fat. Building carbon hypercars is romantic, but in the real world, it doesn't pay the bills. By the mid-2000s, the rules of the game had changed. To survive in an era of strict environmental regulations and economic crises, the company needed more than just posters in bedrooms. It needed hard cash. And then the brand came full circle. Remembering their roots, the tractors and the military LM002, they created the Urus, a super SUV with a twin-turbo V8. Purists cried betrayal of ideals. But the physics of business is just as ruthless as the physics of aerodynamics. The Urus became an absolute bestseller, doubling the company's sales. It was this family SUV that became the financial shield, allowing Lamborghini to keep building insane, impractical supercars with V12 engines. The tractor maker had outsmarted everyone once again. More than 60 years have passed since the day Enzo Ferrari slammed the door in the face of an ordinary farmer. Today, both titans are gone, but their war has turned into a religion. Enzo built road cars only to fund his racing. For him, victory was a trophy at the finish line of a Grand Prix. For Lamborghini, victory is when a 10-year-old child hangs a poster of your car on their bedroom wall. Ferrari is aristocracy and tradition. Lamborghini is rock and roll, ostentation, and a middle finger shown to convention. They didn't just create a brand. They created a dream that doesn't need a racetrack to prove its greatness. But what exactly did Ferruccio buy that day when he decided to take his revenge? He bought immortality. Every time a modern Lamborghini supercar launches from a standstill, that same tractor-like torque still lives in its DNA. It is the physics of an irresistible force. They remained faithful to the naturally aspirated V12 when everyone else switched to turbos. They kept the aggression when the world became too polite. A Lamborghini is a reminder that the engineering genius and stubbornness of a single man can change the course of history. So, did the tractor maker win? If you measure victory in lap times, perhaps Enzo is still ahead. But if you measure it in emotions, in burnt adrenaline, and in the way people's hearts stop at the sight of the Golden Bull, then Ferruccio Lamborghini won this war back in 1963. He proved that physics doesn't care about your background. It doesn't care whether you build tractors or rockets. All that matters is the passion with which you make metal obey your will. Revenge is a dish best served at 350 kilometers per hour. Thank you so much for watching. If you enjoyed this deep dive into automotive history and engineering, make sure to hit that subscribe button. We have a lot more incredible stories, technical breakdowns, and fascinating machines coming your way. See you in the next episode.